Tuned circuits is of two types: single tuned circuits, double tuned circuits. Here it is in the frequency range of 500 to 1600 kilohertz. The uses of the tuned circuits are radio receivers, communication system, parallel resonance in the secondary. So this is a circuit of the tuned circuit. So here RG is the input resistance, and EG is the input supply voltage, and E naught is the output voltage. This is a circuit of the single tuned circuit. Here R1 is much lesser. Okay, so we are ignoring this to R1 and J I omega L1. So the loop equation. So we are taking here loop equation I1 RG. Generally we will take it as I1 into R1, but here it is less. So this is also less. We are ignoring it. So here also you will get the value of that is both are entering. Here it is current I1 is entering, I2 current is not entering. So L1 and M will be in opposite. But here we are not including this one here. Okay. So we are not writing this plus j omega L1 here. We are neglecting these two terms. And so this is the equation. So while writing this second equation, we are with respect to the this R2 into I2. You will have R2 into I2, and then J into omega L2, J into omega L2, and the capacitance here it is minus J into omega C. Okay, and then here we are taking L2 is L and M are opposite direction. Why means its current entering here is dotted, and here the current entering is undotted. So minus here and L2 is plus, both are opposite sign. Okay, and then solving this equation. So I1 we are that is from the first equation we are finding the I1 value and substituting I1 in the second equation, we will get this equation. So output value is equal to, what is output? So here if you see the output value voltage, it is capacitance voltage. So it is capacitance voltage is nothing but what? The current I2 into XC. So substituting this value, we will get the E naught value. So here we are finding the amplification factor. So here amplification factor A is equal to E naught by EG. K is equal to M divided by root of L1 L2, where K is the coefficient of coupling. Here the voltage transfer function is equal to voltage amplification factor. This is voltage amplification factor and voltage transfer function are same. So the graph is drawn between the amplification factor and the angular frequency omega. Okay, and the maximum point is representing it as omega 1. So this is K1, K2, K3. This is the ideal transformer. Ideal transformer, this is the primary and this is the secondary. So the input voltage is V1, the output voltage is V2, the load is ZL, and the number of turns here is the primary is N1, N2. Okay, and the EMF developed in this first inductance is E1, and the EMF developed in the second inductance is E2. The current flowing in the first primary is I1. Here it is secondary side it is I2. Okay, so transformer voltage, this is the transformer, this is a primary winding, secondary winding. Okay, this is the iron core. Okay, there is a winding is iron, over the iron core it is wounded, wire has been wounded. This is N1 by N2 number of turns ratio. Okay, N1 by N2 is the turns ratio A. Voltage, there is voltage transformation V1 of t is equal to Vm, maximum voltage across V1 input voltage cos omega t, which is equal to, we can write it as in terms of N1 d phi by dt. So phi of t is nothing but the flux produced is Vm1, that is V1 maximum divided by a number of turns into omega sin omega t. V2 is nothing but N2 phi d phi by dt. Okay, so with what is V2 of t is equal to N2 into d phi by dt. So what is d phi by dt is nothing but d phi, so that is d of dt of this phi by t. Okay, so I have this is a constant we are taking out. Sin omega t is nothing but cos omega t. So V2 of t is equal to N2 by N1, okay, into this term as what? V1 of t. Okay, and d phi by dt is equal to Vm by N1 cos omega t. Integrating, we will get this value. So now in an ideal transformer, all the flux linkages, all the turns and the voltage across each coil is proportional to its number of turns. So V2 is equal to N2 by N1 into V1. So what is this turns ratio or transformer ratio? Transformer ratio, turns ratio, transformer ratio is equal to V1 by V2 is equal to N1 by N2 is equal to I2 by I1. Okay,